Imagine waking up tomorrow morning, swinging your legs out of bed, and suddenly finding yourself floating toward the ceiling. Your coffee mug drifts lazily through the air. Outside your window, cars are bouncing down the street like beach balls, and birds are struggling to stay airborne. This isn't a dream. Earth's gravity has just been cut in half. What happens next might surprise you. And spoiler alert, it's not all fun and games. Before we dive into the chaos, let's talk about what gravity actually does. Right now, Earth's gravity pulls everything toward its center with an acceleration of about 9.8 meters per second squared. That's why when you drop your phone, it falls. That's why oceans stay in their basins, and why the atmosphere clings to our planet instead of drifting off into space. Gravity is the invisible hand holding our entire world together. So what happens when that hand suddenly loosens its grip? The first thing you'd notice is your weight. Literally overnight, you'd weigh half as much as you did before. If you stepped on a scale and it read 150 pounds yesterday, today it would show 75. But here's the thing, you haven't actually lost any mass. Your body still contains the same amount of matter, the same bones, muscles, and organs. What's changed is the force pulling you down. And this is where things get interesting. And by interesting, I mean potentially catastrophic. Walking would become an entirely new experience. Every step would send you bounding into the air like an astronaut on the moon. Remember those videos of Apollo astronauts hopping around in slow motion? That's basically your new reality. Except you're not wearing a protective suit and you're surrounded by 7 billion other people who are also bouncing around uncontrollably. The learning curve would be steep. People would be crashing into walls, overshooting doorways, and generally flailing around like toddlers learning to walk for the first time. But the real problems start when we zoom out. Earth's atmosphere, that precious blanket of air we breathe, is held in place by gravity. With gravity halved, the atmosphere would immediately start expanding outward. The air molecules, which are constantly moving and bouncing around, would have an easier time escaping Earth's gravitational pull. Over time, our atmosphere would begin thinning out, stretching further into space. The air pressure at sea level would drop significantly. You know that feeling you get in your ears when you're on an airplane? Imagine that, but permanent and much more severe. Lower air pressure means less oxygen per breath. People living at sea level would suddenly find themselves experiencing conditions similar to being on top of a mountain. Breathing would become laboured. Those with respiratory issues would face immediate danger. High-altitude cities like Denver or La Paz would become nearly uninhabitable without supplemental oxygen. And it gets worse. Lower atmospheric pressure also means water boils at lower temperatures. The oceans wouldn't literally boil away, but evaporation rates would skyrocket. Weather patterns would go haywire. Speaking of oceans, let's talk about what happens to Earth's water. The oceans are currently held in their basins, partly by gravity and partly by the shape of the ocean floor. With gravity halved, water weighs half as much, which means it can pile up higher without the same downward pressure. Tides, which are caused by the gravitational pull of the moon and sun, would become dramatically more extreme. Coastal cities would face unprecedented flooding during high tide. But here's the twist. The moon's gravity hasn't changed in this scenario, only Earth's. So the moon would be pulling on our oceans with the same force, but Earth would be holding onto that water with only half the strength. The result? Tidal waves and coastal flooding on a scale we've never witnessed. Now let's talk about something you probably haven't considered. Your own body. Human beings evolved under Earth's current gravity. Our entire physiology is built around it. Our hearts are designed to pump blood upward against gravity's pull. Our bones are as dense as they are because they need to support our weight against gravitational force. Our muscles are as strong as they are for the same reason. Cut gravity in half, and all of these systems start operating in an environment they weren't designed for. Initially, you might feel great. Moving around requires less effort. You can jump higher, lift heavier objects, and generally feel stronger. But over time, your body would start to adapt, and not in a good way. Without the constant resistance of normal gravity, your bones would begin to lose density. Your muscles would atrophy. This is exactly what happens to astronauts in space, even though they exercise for hours every day. It's called spaceflight osteopenia, and it's a serious problem for long-term space missions. Now imagine the entire human population experiencing this simultaneously. The structural integrity of buildings would also be compromised, but not in the way you might think. Buildings aren't going to collapse just because gravity is weaker. In fact, they'd have less weight pressing down on them, which sounds good, right? Wrong. Buildings are engineered with specific gravity in mind. The problem comes from wind resistance. With lower gravity, the atmosphere extends higher and becomes less dense at lower altitudes, but wind speeds could actually increase in certain conditions because there's less gravitational force pulling air downward. Skyscrapers designed to withstand wind forces under normal gravity might sway dangerously in half-gravity conditions. Transportation would be completely transformed. Cars would need to be completely redesigned. With half the weight pressing tires to the road, traction would be reduced by 50%. Braking distances would increase dramatically. Highway speeds that are safe today would become deadly tomorrow. And don't even get me started on airplanes. Aircraft are designed to generate lift by creating a pressure difference between the top and bottom of their wings. With atmospheric density changed and gravity reduced, aerodynamics would be completely different. Every plane would need to be recertified, and many designs might not work at all. Satellites orbiting Earth would also face problems. Orbital mechanics depend on a precise balance between a satellite's forward velocity and Earth's gravitational pull. Halve the gravity, and suddenly, satellites that were in stable orbits find themselves drifting away into space. GPS would fail. Communications satellites would drift off course. The International Space Station would need its orbit adjusted immediately, or risk flying off into the void. Our entire space-based infrastructure would need to be completely reconfigured. Agriculture would face unprecedented challenges. Plants evolved under Earth's gravity too. Their root systems grow downward following gravitational cues in a process called gravitropism. Their stems grow upward against gravity. With gravity halved, plants would struggle with fundamental processes like water transport. Trees, which use gravity to help pull water from their roots to their leaves, might not be able to grow as tall. Crop yields could plummet as plants fail to develop properly. And with the atmospheric and temperature changes we've already discussed, growing seasons would shift dramatically. The psychological impact on humanity would be profound. Imagine the collective panic as people realize the fundamental laws of physics have changed. Religions would scramble to explain it. Scientists would be baffled because, according to our understanding of physics, gravity can't just suddenly change. It's a fundamental property of mass. For Earth's gravity to halve, the planet would need to lose half its mass instantaneously, which is impossible. The cognitive dissonance of experiencing something that shouldn't be possible would shake the foundations of human knowledge and belief. But let's assume somehow humanity manages to adapt. What would life look like in this new half-gravity world? Cities would need to be completely redesigned. Buildings would be shorter and wider to account for reduced structural loads and changed wind dynamics. Transportation would be revolutionized with new vehicles designed for lower traction and different atmospheric conditions. Sports would be entirely different. Imagine basketball with hoops 20 feet high, or Olympic long jumpers clearing 100 feet. New sports would emerge taking advantage of the reduced gravity. Fashion would change too. With less weight to carry, people might wear more layers or heavier materials without discomfort. But they'd also need to worry about accidentally jumping too high and hitting their heads on things. Ceilings would need to be higher. Doorways would need padding. Society would adapt, because that's what humans do. But it would be a painful, chaotic transition, taking decades, if not centuries. The scariest part: this is all assuming the change happens gradually enough for us to adapt. If gravity truly halved in an instant, the immediate chaos would be catastrophic. The death toll from accidents alone would be staggering. But if somehow we survived the initial shock, humanity would face its greatest challenge: building a new civilization in a world where the rules have fundamentally changed. It would be the ultimate test of human adaptability and ingenuity. And while it makes for fascinating speculation, let's all be grateful that gravity is one of those reliable constants we can count on. Because a world with half gravity isn't a playground, it's a disaster waiting to happen.